Hello everybody, and welcome to TMB's presentation of the ProPlex IQ tester. My name is Daniel Sanchez, and I am the product specialist for TMB. We are here to dive into the new feature of our recent version 1 firmware release for the ProPlex IQ tester. We have a lot of exciting updates to walk through, so let's get started. This is the award-winning IQ tester, the first networking diagnostics tool that provides a complete analysis of active network streams and devices. The IQ tester was created to be an all-in-one solution for technicians at the shop or in the field, eliminating the need to carry multiple dongles, single-purpose testers, and even expensive laptops. Network monitoring and troubleshooting various entertainment infrastructures are now available in the palm of your hand. Previously in active development, the IQ tester is now fully released in version 1.0 and offers an improved user interface as well as new advanced features. We are going to begin by showing off the updated PoE tester. To start, we simply connect to a PoE source via the Ethernet cable in the bottom of the IQ tester. The IQ tester will detect any PoE source from switches to injectors. In this setup, we are connected to a ProPlex GBS enabled with PoE. After connecting to a PoE device, simply press the Run Test button on the touchscreen and the results will display on the screen. Voltage detection will be listed as the first test result. In version 1, we have expanded the test results to delineate between A and B wiring modes as either passive PoE, 802.3AF, or 802.3AT. The cable tester is a popular feature carried over from previous versions. This is a simple yet effective pin-to-pin test for 5-pin DMX cables. Additionally, we have an automatic bandwidth test which determines cable performance. This is one of our extremely popular ProPlex DMX cable assemblies, built to order right here in the same building. I'm going to take both ends, male and female, and connect to the top ports of the IQ tester. As soon as the cable is connected, the test will automatically start. As you can see, all results are color-coded. A quality cable with strong soldered connections will report green status on all pins and bandwidth tests. Firmware utility is a brand new feature used for updating our Solaris lighting fixtures. The IQ tester is now capable of storing updated firmware files in onboard memory and feeding them to fixtures via 5-pin connection. First, we will force the IQ tester to behave as a USB device via the settings menu. This will allow the IQ tester to connect to your computer via USB and show the device. Next, we will connect to our laptop with the USB cable. To locate the appropriate firmware file, we are going to head over to our website. At the top of the main page, you will find a firmware downloads link. This will lead you to our cloud-based repository for all TMB product firmware. Once we download the firmware file, we are going to open Explorer and find the IQ tester. In this case, it is listed as USB drive E. Simply drag and drop the firmware file we downloaded into the firmware folder, and that is it. After the firmware file has been loaded into the IQ tester internal memory, we are now able to see the file inside the firmware utility. Next, we will connect to our fixture via the 5-pin DMX cable. The male end connects to the IQ tester and the female end goes directly into the unit we want to update. The final step is uploading the file while checking to make sure your fixture is properly indicating an update. We've given our timecode options a bit of a facelift. While you're still able to both transmit and receive timecode, there are a couple of changes. Notably, both 5-pin ports can be used to send or receive. However, the output port requires a bit higher level input signal to be recognized due to the circuitry protection. We've also moved the LTC signal scope directly into the timecode receiver menu. On the main screen of the timecode transmitter, you will find the standard play, pause, and rewind controls. In addition to those, you will be able to identify a specific start time via a numeric keypad on the touchscreen. We've also included some configuration options for FPS formatting. While both ports can receive timecode data, we are only able to scope the incoming signal via 5-pin input port. Off camera, I have an additional IQ tester serving as a timecode transmitter as a demonstration. As you can see, the receiving unit immediately receives the timecode signal and reports the exact timing with the transmitter. The display time is also color-coded, green for stable detection greater than 1 second, orange for startup and jump, and red for inactivity. You will also see various statistics measuring frames and pauses. Next, we will cover various networking capabilities of the IQ tester and what makes the IQ tester stand out as an all-in-one device for entertainment professionals. To give a sense of the real-world application of the IQ tester, we have a setup micro rig here in the studio with various ProPlex products like GBS, IQ Node, OptoSplitter, and ProPlex software, along with the Solaris fixtures. We connect to the network via the Ethernet port on the bottom of the IQ tester to begin. Here in the network status menu, we can get a general overview of the activity in our network. You will see statistics like link status, bandwidth usage, and packet counters. In the packet lister window, we have a real-time scrolling list of all raw Ethernet packets with color coding depending on what type of protocol. Each packet lists the source and destination IP. We can now freeze this screen and scroll via the touchscreen. In the new version 1 release of the IQ tester, we have greatly expanded the list of detectable entertainment protocols to include MANET2, MANET3, PSN, Dante, and more. Selecting a protocol opens another window, allowing you to view the active stream statistics like packets, source counts, and source list, which list all active IPs that are currently streaming the protocol. Other network monitors include the active device window, which lists all active IP and MAC addresses in the network. Multicast streams, which list all detected multicast streams and switches with multicast support. And LLDP information that show connected switch statistics. Another new feature we've added is the ability to send and receive pings directly from the device. Here in the upper right corner of the ping sender, I can touch the IP field and enter the desired IP address with a numeric keypad. I can configure the size and interval and run the test. Before jumping into the full DMX capabilities of the IQ tester, I wanted to first show the updated RDM functionality. We are still connected via Ethernet to the micro rig, but we also need to be connected with the 5-pin DMX cable. RDM can be used with a cable directly connected to the compatible lighting fixture like the Solaris Razor, or we can route through the IQ node with enabled RDM proxy. In the main RDM device window, you will see the screen divided into multiple panes, with each pane dedicated to one device and its status. Here you will be able to identify a fixture by the manufacturer or model information, as well as the DMX address. Using the touchscreen, I'm able to select which fixture I'd like to modify, which takes me to a separate detailed screen with many of frequent RDM options you would need. Again, using the touchscreen, I can directly edit device parameters like mode, DMX address, label, and more. We have located the Identify button in the bottom of the detail screen to help you easily select and pinpoint the fixture you have selected. This is especially helpful in bigger rigs. Most of the industry standard and manufacturer-specific RDM PIDs are now supported. However, we have also included support for raw PID entry. To test any unsupported or custom get-set messages. Finally, we move to the DMX features of the IQ tester. This is perhaps the biggest change from previous versions of the IQ tester. We have simplified the DMX, ArtNet, and streaming ACN menus into the area of DMX receiving and transmission. Here in the DMX transmitter window, we will introduce the concept of output universes and DMX source editors. On this page, you will see a list of several universes of control via ArtNet and streaming ACN. At the top, you will see the DMX output port, which is the 5-pin output. As you can see, we are capable of outputting multiple network sources of ArtNet or streaming ACN, but only one universe of 5-pin output, since the IQ tester only has one output port. At the bottom of the screen, you will find the Add button. Pressing it will open another universe output for either ArtNet or streaming ACN. After I create the output, I can select the expanding menu button on the right side of the screen. This will allow me to configure, enable, or disable, delete, and view the current outputting DMX. I'm going to select the configuration page where I can set the universe number and destination address for ArtNet and streaming ACN outputs. Here you will also see source options. The source is the origin of the DMX control. These can be simple commands like all channels 0 or all channels full. We can also assign the incoming DMX signal from a separate console, which would be connected via DMX cable into the 5-pin female port on top of the unit. Any ArtNet or streaming ACN universe stream can be used as a source of DMX. Since sources can be assigned to any output, you can reroute the data back through the network via the ArtNet or streaming ACN universe output. Or you can send the data through the 5-pin port via DMX cable, similar to a node. As soon as you select the ArtNet or streaming ACN, you are given a configuration page. This allows you to choose the universe you want to source from and enable the output. The last two sources available are Scene Playback and FX Engine. There are 6 static scenes that can be edited directly or saved to internal memory from incoming DMX data via the DMX receiver, but we'll come back to that later. The FX Engine is a brand new DMX source feature we have introduced in version 1. To show off the FX Engine, I'm going to back out and select our DMX output port, which is connected to our Razer fixture here on the desk. I will configure this output to use the FX Engine as a source. Then I will move into the configuration page to set the various effects. In the FX configuration page, you are given several options to manipulate the DMX stream. The waveform effect can be modified to a specific BPM speed, channel range, value range, and more. In this case, our Razer pixels begin on channel 9, so I'll adjust the range and apply a slow BPM speed. After deciding the effect settings, all changes are presented in a live preview in the upper right portion of the screen. Additionally, we have a full screen preview which is accessed with the View DMX button at the bottom of the screen. Finally, I'll show you the scene manipulation. Like I said before, these scenes can be captured from the DMX receiver or they can be edited directly. We will show you the DMX receiver here in a minute, but right now, I'd like to focus on the new scene editors we've introduced. When you enter the edit scene mode, you will be presented with the first editor type, the 6-channel fader. You will notice the channel range at the bottom of the screen and arrows which cycle between individual DMX channels or groups of 6. Cycling by group is also assigned to the left and right buttons. If you don't want to cycle through multiple pages, you can simply select a manual range by tapping the range and using the numeric keypad. Fader levels are touch sensitive, so we can grab channel 9 for example and drag the fader up. Faders can also be selected with the button pad. Just press the center button to begin a channel highlight. Left and right will select a specific channel and up and down will change the level. Notice at the top of the fader, both value and percentages are represented. Using the buttons will allow more dexterity to select a specific value. As each button press moves the channel by a value of 1, you can also hold down the button to increase the speed of the selection. You will also see a View DMX button, which shows a preview of the changes we've made so far. You will also see a Clear Values button in the lower right of the screen, which will reset all faders to 0. If you prefer viewing less channel faders, you can try the 4-channel editor, which behaves exactly the same way as the 6-channel editor. For those who are more familiar with numeric channel editing, you can use our CMD keypad editor. Here you will find a usual set of operating keys such as through and at. I'll select a channel range 1 through 17 and set them at value 75. You know you are value editing because of the 255 button in the upper right hand corner. We can also switch the percentage editing by touching this button once. You'll see the same clear values and View DMX options carry over from each editor. Last up are a couple of new editor styles for RGB and RGBW pixels. These editors are perfect for multiple cell fixtures that are used for pixel mapping. These editors group by pixel instead of channel range, and each fader is color coded. You will have the option of affecting all pixels or single pixels. In the case of single pixels, these navigate in the same way with arrows or buttons. Single pixel editing also has the option to add or clear. If you select clear, all previous changes to DMX values will reset to 0. Pixel add does the opposite, and all changes will remain. Here we are finally in our DMX receiver window. Just like our transmitter, all received DMX packets from either ArtNet, streaming ACN, or 5-pin input will show you on this screen. Active streams will indicate the protocol type, source IP, and will show you a packet counter in real time. Simply touching the middle area of the stream will bring up the live DMX view. This view can be displayed in a variety of formats, such as 48 channel bars, 512 channel bars, which is the default display you just saw, 512 channel grid, RGB grid, and RGBW grid. These views are just different ways of representing the incoming DMX information and can be used interchangeably to your preference. Here, I'll select the 512 grid. Each square in the 512 grid represents a DMX channel, 1 through 512. Values are shown as intensity of green, where the brightest green signifies at 100% value level. The RGB and RGBW grid, like our RGB and RGBW editors in the DMX transmitter, are organized by pixel. Each square in the grid is a representation of a pixel. Values are represented by actual color approximations of RGB or RGBW, and also the intensity of color, where the brightest is the highest value. Another popular feature that was carried over from previous versions is the flicker finder. This can be applied over to the 48 channel and the 512 displays. Simply select the type of flicker finder mode, either hold or fade. When using the fade mode, you can configure the fade time up to 10 seconds or 10,000 milliseconds. And finally, if you are receiving a specific stream of DMX that you'd like to record to a static scene playback slot, you can do this from the main menu. Simply select the expandable menu on the right side of the active stream and select Stored Data. From this menu, you can enter the storage destination and whether you'd like to overwrite or merge with a currently saved scene. We'd like to thank you for joining us for this IQ Tester version 1 walkthrough. As a reminder, the IQ Tester is continually updated through recommendations of users like you. If you own an IQ Tester and you are excited about this release, please join the discussion pages at forum.tmb.com. If you are interested in a demo or purchasing, please contact our global sales team at sales@tmb.com. Have a good one.